Uh, Good morning, everyone. My name is Hari Krishna. I'm going to present on uh, how can we do dump and restore the extended statistics using the utilities GPSD and minirepro in Greenplum 7. So in Greenplum 7, we are supporting the extended statistics, which means that optimizer using the statistics to generate the best optimized plan. So today's my agenda is uh, these are what are the basic statistics and limitations of basic statistics and benefits of extended statistics, and a quick demo on how to create the extended statistics and how can we do dump and restore using the GPSD and minirepro utilities. Yeah. So we all know that the basic statistics are like column level statistics, column based statistics. So some of these statistics are like number of distinct values, like estimate the number of distinct values of each column in a table, and total number of values. Estimate the total number of values in each column of a table, and null values statistics, same thing like that. It calculates the number of null values in each column in a table, and histograms of a columns with numeric or data types. So these statistics we can see in PG stats table. And there are the limitations with the basic statistics and why we need to go why we need an extended statistics. Some of the limitations are these are like skewed data distribution. The basic statistics may not accurately capture the distribution of data in columns with skewed or uniform data distributions. For example, if a column has a few values that occur very frequently and most values that occur very infrequently, the basic statistics may not accurately represent the true distribution. This can result in inaccurate cardinality estimates and suboptimal query execution plans. The correlation between the columns. The basic statistics do not capture the correlation between columns in a table. The columns that have a high degree of correlation may have different selectivity when used together in a predicate compared to when used individually. The basic statistics may not capture this correlation, leading to uh, suboptimal join order or join type decisions by the optimizer. And the next one is complex data types. The basic statistics are limited to certain data types, something like numeric and data types, and may not be available for complex data types such as arrays, histograms, histor, or JSON. This can lead a limited information for complex data types, leading to same as less accurate cardinality and selectivity estimates. So other one is like dynamic data distribution. The basic statistics are collected during the table statistics collection or query planning time and may not accurately capture the changes in data distribution that can occur over time in dynamic databases. The changes in the data distribution due to updates, inserts, and deletes may not be reflected in basic statistics, resulting in a suboptimal query plans again. And predicate combination. We all know that basic statistics do not capture the combined selectivity of multiple predicates applied together in a query. When multiple predicates are combining using logical operators like and or kind of the selectivity of combined predicate may not be accurately estimated based on the individual basic statistics, leading to these are all leading to inaccurate cardinal and selectivity estimates again. So if you see in a complex queries where the data distribution is a complex, correlated columns are involved, and dynamic changes in data distribution occur, basic statistics may have limitations in accurately estimating the cardinality and selectivity and other statistics. In such cases, extended statistics may require to optimize the query execution plans selectively. So these are some of the benefits of using the extended statistics, like we can enhance the cardinality estimates and improve the predicate selectivity estimates and better joint type selection and accurate cost estimation. Overall, if you say external statistics can provide additional insights to the optimizer, allows it to make more informed decisions about the query execution plans. This can lead to improved query performance and reduced query execution time and better resource utilization in complex query scenarios where basic statistics may be limited in accurately estimating the cardinal and selected other statistics. So let's jump into the demo. So my demo goes like how to create external statistics and how can we do dump and restore. And the utilities, we all know that GPSD and minirepro utilities. These utilities are useful for uh, reproducing the uh, production environment issues like query plan changes or inappropriate query plans or query got crashes kind of issues. Uh, Using these utilities, we can capture the source database catalog information and statistics, and uh, can be applied to the local database and can reproduce the scenarios, and we can make through these utilities we can come up with a quick RCA for the issues which we see in production environments. So we all know that GPSD is a utility used to collect system catalog plus PG stats information. It's kind of a replica of the source database. It's used to collect it. So and minirepro is kind of a smaller version of GPSD, and it used to collect the PG stats involved in that query execution. So for these two utilities added additional capability to capture the extended statistics in Greenplum7. So let me stop it here and we'll run through a demo. Okay. Let me share my screen where I can show them. Okay. Let me create a test database. Create db gpsd underscore extended statistics. So already exists. Let me jump into the database psql-d gpsd underscore ext. I see there is nothing, no tables exist. Let me create a tables. Create table T, int and the int, and insert data. Insert into T. Select I mod 100 from generate series. I just add 10,000 rows. Can we? So before we see into the external statistics creation, there are two tables that we need to know, like where the external stats can be created and how the data will be stored. So start from pg statistic underscore ext. So this is a table will holds the information about the external stats that we creating. It's like a catalog for the external stats, and the data will be stored under ext underscore data. This is a place we can see all the three types of statistics, like distinct type between the columns and the dependency between the columns and the MCP values between the columns. And here we can see that the PG class entry of the stats that we are creating out of it, and what is the stats name and OID of this entry, unique identifier, and the namespace it has created, and the owner, and the keys means like what are the columns you've been involved in the stats and what kind of stats it is. Okay, let's create a stats for the table T. Create statistics. So this is the command we use for creating a statistics. Create statistics. Let me create stats1. I'm creating like dependencies and n distinct and MCVs. I'm creating all three statistics for the table T on columns A, comma B from table T. Dependencies. Sorry, a typo mistake. Distinct. Okay. Now we can see. Now let's see how the tables got updated. So now we see that there is a stats, uh, external stats entry is created for the table. The PG class entry of OID is 27579, and the new OID is created for the stats entry, and namespace is 2200. It's a public, and the owner and the keys 1 and 2 means like what are the columns, like column 1 and 2, A and B, and the kind of statistics what we created for the stat 1 is like dependencies, uh, distinct and functional dependencies, and MCVs. These are the stats we created for the table T. So let's analyze T, and let's see the data how it will. So it's so clumsy. Let me print it. Distinct values and dependencies and PG MCV list items of MCVs. So we can see the distinct values. One column 1 and 2 are 10,000, and functional dependencies are 100%. One column between A and 1 and 2, and these are the like common values MCVs for the combinations. So that's how the data will be get updated. Okay. Now we have stats in my database, and let me use the utilities like GPSD and minirepro. How can we dump and restore, and we'll see. So we all know GPSD, and the database that I am need to be backup, which is GPSD underscore ext, and I'm putting it into GPSD dump dot SQL file. So there is no change in usage of GPSD utility. So we can just quickly go through the what it has collected for external stats. So we can see that here. So we can see the entries for the stats 1. The table PG stat ext data for the stat 1 schema public. We have a command like update. So this got been backed up. So now I need to apply this. Let me drop my database, delete db, sorry, drop db gpsd underscore ext. Okay. So now I drop my db, and I creating my db gpsd underscore ext. So PSQL -d gpsd underscore ext. So if you see, there is no entries for the external stats now. In the sense, this is all together like a target database. The source database we already took a backup. I'm just trying to apply the stats into the target database. So let me apply SQL -f, and the file that I have taken backup is GPSD and dump SQL, and the database is GPSD underscore ext. So I just updated my database with what are that I have taken a dump. So let me get into the database and see whether we have backup has been come up or not. -d gpsd underscore ext is the data, and so we can see that what we have taken a backup is stats1, which used to be in a source database that we have created, like kind of stats it has available, like dependencies and distinct values and MCVs. And we can also see uh, the ext underscore data table which has been backed up. So the same, everything is backed up into my source. This is how we can be backup. You can dump and restore the external statistics using the GPSD utility. And it is like it creates same replica of the source database, so that you can easily reproduce the query which has actually had an issue in the production environment. So let me give the same uh, the feature with minirepro, how it works. Let's see. Let me create another database, create db and gpsd underscore minirepro. Minirepro. Okay. So SQL I just go and create into the just get into the database and create the table, same as like GPSD. Create table T, int, ambient, insert into T, select, comma I mod 100 from gender series. Okay. Let me see, my table as created, and I have inserted some 10,000 rows. So unique values are like around 1,000 unique values you will find each bucket, distinct values. So let me create a stats out of it. Create. So for that, I'll just show you like. So we don't have any stats currently. So let me create a stats out of it. Create statistics. Stat true. Can be given one as well, but previously I have created, so just creating stats2. So dependencies in distinct and MCVs. I'm creating all stats on A comma B from T. So now we can see we'll be having an entry for the stats, extended stats, and if you see data, there won't be data unless we analyze the table. So we'll see the raw data for the MCVs. You can print this in a binary. You can see raw data, and we can print this in a with using a function called as pg list MCV list. It will print in a readable format. So this will says like one is dependencies and one other one is like distinct values. So this is the distinct values between the column 1 and 2. How many are there? These are like dependencies. How much dependency it is, like 100% kind of. So let's see how can we do the same thing for the minirepro. So minirepro needed a query for taking a backup, because it's used to be take a backup of only stats required for the query involved in that query involved for issues. Now we are adding a feature for the external stats. Now previously it used to collect stats from only PG statistics. Now even it collects from the PG statistic ext and ext data. So let me create a query, test query, test.sql. So what my query is, select star from B where A equal to 1 and B equal to 1. So now we can see that to run this query, it needed the stats for the table T. What are the stats which are involved in columns? So the minirepro. So it basically need a database, and database is my database is which is GPSD minirepro, and -f my query file I had to give, which is test.sql. And this is the one, I think. Let me reconfirm. -f database query. Okay, so -q is the one for query file and -f is the one for output file. So output file should be like minirepro underscore dump. Run this. Okay. Now, if you see this, let's see this minirepro dump, how it looks. So you can say the dump has been updated in this file. So you can see that for the stats2 of the schema public and for the table data. The same thing even for the stats.txt also updated in this file. Yes. So let me drop this DP and try to restore the database by using the minirepro.dump file. Okay, let me drop DB minirepro. Yeah, I would have been given a better name, minirepro underscore DB kind of drop DB and minirepro. Okay. So let me create DB. Okay. Let me apply the backup file from the minirepro. SQLife and what is the DB that I created is this and -f. What is my not this dump file? Yeah. Now we can see now. Let me get into the DB. SQLife and D. So we have a table here and we have information on entries of the extended statistics we have here, and the information of extended statistics data will be available here. Yep, we have this raw data along with distinct and dependencies values. So let me summarize the overall. Like I just created a database and created an extended statistics out of it, and then tried using the GPSD and minirepro utilities to back up the complete database based on the query for the minirepro and complete replica of the database GPSD. It takes the system catalog as well as the PG stats along with the extended stats. Now it has taken a backup and I created a DB again and try to apply that, restore those databases back so that we can restore those databases back and we can reproduce the issues and can come up with a RCS quickly and in-house. So that's all about my demo on extended statistics. How can we do remove? How can we do dump and restore using the utilities like GPSD and minirepro? Thank you. Thank you everyone for joining. Have a nice day. Thank you. Bye-bye.